You, yes, am I audible now?
Yes, sir, you are.
Yes, thank you. Yes, good evening, ladies and gentlemen. My name is Vengat. I am from Aqua Connect, and I am delighted to be here today to share my knowledge and insights on how the TensorFlow is used to improve the efficiency in aquaculture. And with over 16 plus years of experience in the software industry, I had the chances to work with many innovative solutions and technocrats and leveraging cutting edge technologies to drive the positive change. So MIT awarded me as a prestigious Social Innovator Award for my contributions to the Mobile Semantic Search project. And this groundbreaking technology enables non-data consumers to access the web content effortlessly and simply making the voice call. So during my journey, I have been witnessed to the rapid changes and transformations in the technology. It is truly remarkable to observe how we transitioned from landline phones to smartphones in less than 2 decades. The pace of innovation has been nothing short of astonishing, and same thing happened in the AI world as well. Here we explore the powerful role of TensorFlow, a groundbreaking machine learning framework, in boosting efficiency and sustainability within the aquaculture industry. We will discover how the sophisticated technology has empowered fish farmers to optimize the productions, monitor water quality, predict disease outbreak, and make data-driven decisions that lead to improved yields and environment of stewardship. I have strong belief that the insights shared today will not only showcase the incredible strides made possible by TensorFlow, but also ignite a passion for innovation and collaboration as we work towards more efficient and sustainable future for the aquaculture industry. So without any delay, let's embark on this journey together and evolve into the vast potential and transformative capabilities of TensorFlow, which has the power to revolutionize the aquaculture efficiency. And we are standing at the forefront of technological revolution in the era where AI has evolved beyond the realm of science fiction to become an integral part of our everyday lives. It's driving advancements in everything from healthcare to entertainment, from transportations to every ways we communicate and interact with the world. In this rapidly changing landscape, it becomes paramount for us, the next generation of innovators and thinkers, equip ourselves with the understanding of the tools that are powering this revolution. One of these powerful tools is TensorFlow, a state-of-art library that has proven to be a game changer in the field of machine learning and AI. Today we will embark on journey to understand TensorFlow in depth. So we'll unravel what exactly it is, its fundamental structure, and how it allows for advanced computations. But understanding a tool isn't just about knowing its nuts and bolts. It's also about recognizing why it matters. So we will explore why TensorFlow has emerged as a preferred choice for professionals in the AI industry. But we don't stop there. We'll also see TensorFlow in action by, by delving into real world applications with a special focus on projects related to aquatic environment. This will help you appreciate how theoretical concepts translate into impactful real world solutions. Whether you are a professor, PhD scholar, or data scientist aspirants, or enthusiastic computer science students, are simply curious about the buzz around AI, ML, this session is designed with an aim to spark your interest and deepen your understanding of one of the most powerful libraries in AI. By the end of our time together, my hope is that you will not only gain a robust understanding of TensorFlow, but also appreciate its significance in our AI powered world. So, there are many buzzwords. What is machine learning, deep learning, AI, TensorFlow? So let's dive into one by one. And think about machine learning is teaching a computer to learn from experience, much like we humans do. You feed a computer lot of data and give it a task, say, to identify whether an email is spam or not. Over the time, the model learns the patterns in the data that indicates spam emails. It can then use these patterns to decide if a new email has never seen before is a spam or not. So, machine learning is like teaching your computer to make decisions or predictions based on patterns it has learned from previous data. Now the deep learning is it's a subset of machine learning, but it works a bit differently and handles more complex tasks. Imagine teaching your computer to recognize a picture of cats. Cats can look very different depending on their breed, size, color, angle of the photo, and many other factors. Deep learning models, especially ones called the neural networks, are good at handling these complexities. We will know more about neural networks in coming. So they process in the layers with each layer learning to recognize different features of the image. And together they can recognize a cat in variety of pictures. So while deep learning is a part of machine learning, it uses a layered approach to learn from data, which allows it to handle more complex tasks. Finally comes to our TensorFlow. What is TensorFlow? Like TensorFlow is like a set of tools for machine learning and deep learning. Just as you might use a calculator to help with the math, right? So you can use a TensorFlow to help build and train your machine learning or deep learning models. It provides a lot of pre-built functions and structures like those layers I mentioned earlier that makes it easier to set up and run with tensors, which are generalization of vectors and matrices, and flow refers to the flow of computations through a graph. It's a popular tool because it's a powerful, flexible, and can even be used to run a model in real time on various devices, from computers to smartphones. Yes, nowadays you can run or train a model in the smartphone itself. So, in short, machine learning is like teaching your computer to learn from experience. Deep learning is a more complex subset of machine learning that uses layered structure called neural networks. And TensorFlow is a tool. You can use it to do both machine learning and deep learning. So, what is machine learning actually? Now, in that machine learning is truly remarkable in these predictions to becoming more accurate as we provide more data. It is not about explicitly programming the computer to perform each task, but letting the machines learn on its own from data. This ability to learn and improve is what sets machine learning apart and why it's a virtual tool on our data rich world. So, you have likely encountered AI ML in your daily life, perhaps without even realizing it. And so, we also come across one word AI, right? So, AI is nothing but it's artificial intelligence. It is like giving a computer a brain of its own. It's all about creating a system that can perform tasks that usually require human intelligence. For example, is NLP. NLP is nothing but natural language processing, and it's commonly called NLP. It is a fascinating field of artificial intelligence that focuses on interaction between computers and humans using natural language where humans speaks. Especially, it's all about how each we teach the machines to understand and respond to our language, just as other humans do. When you ask Siri or Alexa a question and they respond, or when you type a query in Google and it understands what you are looking for, and even with the typo, it can give you the answer, right? So that's the NLP at work. Furthermore, the advancement is deep learning and neural networks is given a rise to transformative NLP models like BERT, BARD, ChatGPT. Now ChatGPT Plus is the latest one, I guess, and pushing the boundaries of what machines can understand and generate in terms of human language, right? And then it's predominantly used sentiment analysis, and it determines whether the piece of text is positive, negative, or neural network, and it has many much more use cases and real world applications. For example, sentiment analysis is itself is a vast business. It use it to understand the customer sentiments for the company about their products and services, and politicians uses it to gauge public opinion whenever no they are coming up with new policies, and it even used in social science research. And and the next powerful thing is like recommendation engines, which we are no it is largely affecting each and every persons, I would say. So, for example, when you are a Netflix or Amazon Prime, It suggests a movie or TV shows you might like. Or when you are shopping on Amazon or Flipkart, it recommends your products based on your browsing history, right? And this one is killer. Like when you open a YouTube to watch just a one short video, thinking it will only take a minute or two, right? But one video leads to another, and before you know it, boom, 3 hours have passed. It is like you have been on a video marathon without even realizing it. That's the magic, or rather, the sneaky trick of YouTube's recommendation engine. So, so here that when the deep learning is a branch of machine learning, right? So, which in turn is a subset of artificial intelligence. It is inspired by the structure and the functions of the human brain, especially the way our neural network operates. Hence, it's often linked to concepts called artificial neural network. And imagine you are trying to catch a ball. Your brain instinctively estimates the ball's trajectory, speed, direction, and send the signals to your hand to move in a particular way. So that's your neural network at work. Now, deep learning is trying to replicate the process in the artificial neurons. So that's deep learning. Then, then what is the neural network? So you so you might have a single layer of neurons and each one processing an input and giving an output. Actually, it is replication of the neurons in your brain and it is connected each other. And it helps to remember the data or things you are seeing, which, which goes to the long-term memory. And the same way, here in the deep learning, they are trying to replicate it. So we have a multiple, sometimes even hundreds of these deep learning models. And each layer learns to recognize increasingly complex patterns based on the output of previous layers. So that's the deep, like here, they are meaning a deep learning. And if you take our previous example, deep learning model designed to recognize the images of cats, right? The first layer might learn to recognize the basic shapes, and the next layer is recognize the texture, then patterns, then components like eyes, ears, and finally last layer can recognize a cat as a whole. So that's how our deep learning layers works. So you might wonder why the deep learning is getting much more popular in last couple of years. So it is exciting because um, deep learning has gained much more popularity, right, in recent years. Well, the answer lies in these three key factors. One is data availability, because like everyone is lives in social media, like data is available everywhere from the smartphone to, yeah, and then computational power. has been increased exponentially and the advancement in the algorithm as well. Okay, let's deep dive into one by one. In that, so in the digital era, we are generating numerous amount of data every day from social media posts to digital pictures and videos, and GPS signals and transaction codecs and more, right? This abundance of data is fuel for the deep learning models, which is never possible before. So just like we learn from the experience, these models learns from the data. The more data we feed into them, the better way it learns, right? Secondly, we are now having more powerful and affordable computational resources. So, thanks to advances in the hardware technology, graphic process unit, and GPUs and Tensor processing unit, also called TPUs, have become more accessible and efficient, which are vital for training complex and large-scale deep learning models. Also, cloud computing platforms like Google Cloud, Amazon AWS, Microsoft Azure, etc., have made it possible to access high computational power on demand. So we don't need to buy it. Whenever we need it, we just create the machine learning high powered EC2 instance or something like that. Once you use it, you can shut it down. It's not possible before, right? And then one important advancement in last two decades are have seen the significant advancement in the neural network algorithms. So making them more efficient and accurate. For instance, the development techniques like convolutional neural networks for image processing and recurrent neural networks, also known as RNNs, for sequential data, and transfer learning have revolutionized these fields of deep learning. When we combine these factors, it allows deep learning models to excel in tasks like image and speech recognition, natural language processing, and many others, often surpassing human level performance. That's why industries across the spectrum, from healthcare to finance, from self-driving cars to entertainments, are harnessing the power of deep learning. So the rise of deep learning isn't just a trend, it is a major leap forwards in the field of artificial intelligence that's fueling a whole new generation of applications and the services. Now we are coming to our topic, TensorFlow. So, what is TensorFlow? TensorFlow is relatively very new and one of the coolest kids on the block in the field of artificial intelligence. TensorFlow is an open source library developed at the Google Brain. It's primarily used for machine learning and deep learning applications. But the fun part is its capabilities is go beyond that. So you might wonder why it is named TensorFlow. In the realm of machine learning, A tensor is a mathematical term for a type of multidimensional array. With the TensorFlow, we can manipulate these tensors with the operations and flows, hence the name TensorFlow. So let's take a moment to understand what a tensor is, especially since we have been discussing TensorFlow. In the simplest form, a, a tensor is a container that can house data in n dimensions. The best way to understand a tensor is by comparing them to things you are already familiar with. And is a 0D tensor. It's a scalar. It's just a single number or a scalar. For example, the number 5 is a 0D tensor, like or the 3.4 float, true, false, right? So number is a 0 or ones, right? So this is a 0D tensors. Then it's a one dimensional, it's 1D tensor. This is a one dimensional array of numbers or vectors. For examples, array of 1, 2, 3, 4, 5. It's a 1D tensor, it's vector, right? And then it's a 2D tensor. So this is the two-dimensional array of numbers or matrix. For example, a spreadsheet with the multiple rows and columns, right? This is the 2D tensors. And then is a 3D tensors. You can imagine a cube, right? Is a 3D tensors. So it is where it starts with little tricky. A 3D tensor is a extension of the 2D matrix, right? Into the another dimensions. If you think of a 2D tensor is a matrix, is a rectangle filled with the numbers, right? So 2D tensors would be like a box or a cube filled with number. Right. So let's try to visualize this with the real world example. Imagine a colored image, right? A colored image can be represented as a 3D tensor. An image is typically consists of three colors, right? Red, green, blue. So if we have an image with 200 cross 200 pixels, this would be represented as a 3D tensor with the dimension of 200 width and 200 height and cross three colors channels, right? So each pixel of the image is assigned a triplet number RGB that determines its color. So then, like we can have a 4D tensor, 5D tensor, etc., so on. These are harder to visualize, but they follow the same concept. In NT tensor is a mathematical object that's analyzed deep and can carry information in multiple dimensions. So here, TensorFlow works around the concepts of computational graphs, also known as data flow graphs. It is a form of directed graph where nodes correspond to the operations or computations. The edge corresponds to the tensors data and that flow between these nodes, right? So let's break this down. Nodes and edges. Nodes, each node in the graph represents a mathematical operations like additions, multiplications, or more complex functions like rectified linear unit, which are common in machine learning algorithms, right? REL. Edges. The edges of the graphs are the tensors, that is, multi-dimensional data arrays. An edge carries a tensor from one node to another, indicating that output of the operations at the first node is the input for the operations at the second node. Data flow graph in TensorFlow is the heart of its performance, efficiency, and scalability, and making it a great tool for machine learning tasks. So here, why the TensorFlow JS? So that you can train or run machine learning models directly in the browser. So that's the power and beauty of the TensorFlow JS. This opens up the world of possibilities for interactive web applications that can benefit from the machine learning. Running a model in the browser allows for real-time interactions. Users can interact with the machine learning models in real time, making it possible to create highly interactive applications. And TensorFlow JS allows you to perform uh, transfer learning in the browser itself. This means that you can pre-train model and perhaps train on a very large data set and customize it to the browser with a smaller amount of user specific data. Right? So in that, in the one more advantages is that it can run on everywhere. If it is a smartphone, Raspberry Pi, like a Mac Mini or Mac Server, Windows Server, Linux, it doesn't matter. If you have a model, you can take it to anywhere and you can run it anytime. That's very beauty of this one. Hmm. Then it has a power of parallel computations. So just as you might use your laptop and phone at the same time to get works done faster, TensorFlow can use the multiple processing units in your computers like CPUs and GPUs, right? So it can use the multiple processing units at once. It clearly figure out how to divide tasks between these devices to maximize the speed and efficiency. And if you are a tech expert, like you can even manually instruct a TensorFlow to perform certain tasks. Uh, is it like Is it okay now? I'm sorry, like now only I'm seeing your chat messages.
Yes, sir, it is okay.
It's okay now? Okay.
It's
Yeah.
okay now, sir.
Sorry. So that power of, uh, is just like you might use your laptop on phone, right? So you can even manually inspect. So that's how it's working. Mm, okay, fine. And imagine that you are instead of no, just your friends helping you with assignment, your entire class is working together. That's similar to distributed computer, where computations are spread across several computers in a network. This allows TensorFlow to process incredibly large data sets and models that a single device that couldn't be handled, right? So it is also synchronous in nature. TensorFlow has a clever trick where it can start a later part of the task while it is still working on the earlier part, as long as the latter part doesn't depend on the earlier one. And think of it as a starting to write your conclusion while you are still researching on a topic. You can do both simultaneously, which speeds up the whole process, right? And one more advantage is for this one is it has got a vast amount of community in the worldwide network of developers, researchers, engineers, even the enthusiasts who contribute to the useless TensorFlow. As my and it has thousands of contributors all over the globe, right? Mm. And many of the since it is banned from the Google, like the Google is like many of the service is powered by the TensorFlow. So it uses their operations. Google, no, it also uses TensorFlow in multiple ways across the various applications and various that collect students might be very familiar with it. And especially the Google search is plays a crucial role by TensorFlow in improving the accuracy and relevance of text results in Google search. So it used for understanding the context of the search query and returning the most relevant result. Again, the Google Photo is one of the most popular services to recognize the image capabilities. It's again powered by the TensorFlow. It can recognize the objects, places, peoples, and even activities in the photos. So, this is what enables you to search your photos for specific items like peach or dog and get accurate result. And again, the YouTube is powered by its recommendation engine. We have already seen it, and it helps analyze the user behavior and preference to suggest videos. Right. And Google Translate is again one of the most powerful natural machine translation system used in the Google Translate. It improves the translation quality and enables the system to translate the whole sentences at a time, maintaining the context and accuracy. Again, most popular, Google Gmail also used and TensorFlow, again, the Google Assistants. It It understands your commands accurately and uses the natural language processing to speech recognition in the assistance. So again, like, yeah. Now we use, so here we use couple of projects for TensorFlow especially. Let me explain brief about how we have run these models and how we TensorFlow helped us to get the results. So in aquaculture, identifying the pond, where is the pond is available, is a tedious job. It is nowhere is available. Even government data websites, if you see, part and partially, yes, there is a lat-long location of those ponds are available, but that is also not in a right way. It is a, first of all, it's a very crude way. They have marked those boundaries, and those boundaries are like very old, 5 or 6 years old, and that boundaries are most of the times is nowhere related to the current systems, because sometimes farmers are converting ponds, multiple ponds into one pond and one pond into multiple ponds. The size and shapes also varies. It's no more relevant. So we thought of using machine learning model and using satellite images to mark the boundary across India. And as we did it, we can able to mark boundaries across India. And this is how we did it. So first we used UNet model. It is one of the powerful deep learning model used for image segmentations. So it helping us to identify, understand the individual elements of an image, right? So first for training data, we marked boundary manually. If you say in the second image, the boundary is marked by our ground team. The first image is the original satellite image we have shared with them, and then they mark the boundary, and we'll create the labeled data. So in machine learning we call it like labeled data. It has only a Unicode data, zeros and ones. We will convert this data into zeros and ones to just identify the boundary, right? So we have just created 300 such images, and then using image augmentations, we just created 300 images into 50,000 images. So augmentation is nothing but, so use one images, just tilting little bit and are flipping it, cutting it, scaling, scale up, scale down, whatever you can do. So by this augmentation, we just increase our training data set to 50,000 images. And with the help of 40 epochs, we trained this unit model to improve the accuracy of our model. And now I would proudly say we marked more than 80% of the ponds across the India. So this is one of the remarkable achievement we did with the help of TensorFlow. And I proudly say this kind of data is nowhere it's available other than with us. So you can see how accurately it has predicted the pond boundary. Even in that prediction, our ground team data has missed a couple of ponds, but after training the model has predicted whatever the boundary our ground team has missed it. And And in that aquaculture, one of the significant factor whether the aquaculture pond is live or not. Like live means whether the pond, the culture is happening right now or not, is one of the parameters finding the aerated in the pond. So again, to identify this one, like we used YOLO, and so again, when it comes to the YOLO, it's one of the most popular, algorithm to understand the images. So just like human do, right? So we are talking about the field of computer vision. So YOLO is again the state of art detection. Like it is also very new to this field. Like when you look at different part of an image in multiple times, so it recognizes glancing once itself, you can able to identify it. So making it, so this is the feature making it super fast. And this is also we can not only able to identify the ponds across the India, we can also say whether the pond is active or not. We can able to come to that conclusions, right? So this is also one of the groundbreaking achievement we did using the TensorFlow. Not only that, not only see these two models, we run it using only remote sensing data, right? Satellite and remote sensing data. And we also gather data from various sources, including internal and external systems and mobile applications, third party sources, farmers. We are working with around 60,000 farmers, agencies and partners, exporters. Yeah, as you know, we are also using satellite and remote sensing data. So this collection process enable us to develop an advanced engine that enhances our ability to predict warehouse stocking, sales forecast, and harvest readiness. Right. So this then it can be. We are also expanding these use cases. So now we are trying to use these models to remote monitoring and control our ponds, and how we can monitor the environment and mitigate the risk, and traceability and quality assurance also we are trying to, right? So this is how the TensorFlow is used as. And see, if you want to know like more about TensorFlow and you want to see it in action, I would say no, TensorFlow Dev Summit 2020, like it's resources where you need to go and learn more about TensorFlow. Mm, uh, yeah. Yes. So thank you very much for your passion and attention.